So we will start from group number 1. Who is our representative for group number 1? Once that maka-present na mo, automatic you will have a 10 points for the participation. Okay? And then later, I'll ask question if ever there are clarifications. Okay? But if you can answer those questions, no need for me to ask. Or if ever there are questions from your classmates, then they will raise it, of course, to our reporters. Or pwede ang members mag-help. Okay? All right. Presenters, please turn on your cam. So with the members. Okay, are you ready, group 1? Okay na? Sige, start. Noted, Rupert. Other members?
Wala pa si Jade, sure.
So, not ready pa, group 1? Where is JBI?
Wala lagi siya, sure.
O sige, let's proceed na lang sa kindly contact Jade. Reporter siya. Okay. Let's proceed to group number 2. Hydroelectric power plants. Group 3 and 4, kindly prepare para paspas. Okay, Judy.
Good afternoon, everyone. This is Group 2, and we're going to talk about hydroelectric power plant. The main purpose of a hydroelectric power plant is to store energy by pumping water up into the upper reservoir during low demand periods and generate power by releasing the water back to the turbine during high demand periods. Water gains potential energy just before it spills over the top of a dam or flows down a hill. The potential energy is converted into kinetic energy as water flows downhill. A hydroelectric power plant convert the potential difference of water convert the potential difference of water into electricity by transferring it between 2 points at different heights or elevations.
There are two types of hydroelectricity production: dam and run-of-river. A dam is a large barrier constructed to raise the level of water and control its flow. A typical hydroelectric plant is a system with three parts: a power plant where the electricity is produced, a dam that can be opened or closed to control water flow, and a reservoir where water is stored. The water behind the dam flows through an intake and pushes against blades in a turbine, causing them to turn. Hydropower works by harnessing the energy that comes from the flow of water through a turbine connected to a generator, thus turning it into electricity. Most hydropower plants store water in a dam, which is controlled by a gate or valve to measure the amount of water that flows out.
Large hydroelectric generating stations derive energy from an elevated source of water. These hydroelectric power plants use falling water to drive turbines. Hydroelectric power plants are usually found near a big river. Water from the river is collected in a dam, which then regulates water flow into a turbine that rotates the generator. This results in the production of electricity. Run-of-the-river hydroelectric systems are hydroelectric systems that harvest the energy from flowing water to generate electricity in the absence of a large dam and reservoir, which is how they differ from conventional impoundment hydroelectric facilities. Run-of-the-river primarily uses the natural flow rate of water to generate power instead of the large distance. The first law of thermodynamics can be applied to a hydroelectric power plant, which means that energy cannot be created or destroyed. It can only be converted from one form to another. It simply states that part of the heat transferred to an object is used by this object to do work. Because of falling water, since the turbine drives the alternator coupled with it and converts mechanical energy into electrical energy. This is the basic working principle of hydroelectric power plant. The device that drives the electric generator is the turbine. Work is done against the blades, which are attached to the shaft. Shaft rotates the turbine and produces work. The water running through the pipes encounters drag forces from the pipe walls. The water hitting the turbines generates some heat, as does any type of collision. The water leaving the turbine still has some kinetic energy, which is the energy not given to the turbine.
In kinetic power plants, such as the hydroelectric power plant, the falling water turns the turbine. Water acquires potential energy as it is stored behind the dam. This potential energy is converted into kinetic energy as the water flows through special channels that lead to several turbines. The water rotates the blades of these turbines, which then turn large magnets or coils of a generator. The generator transforms kinetic energy of its coils or magnets into electrical energy. The water then continues its flow through the river for recycling.
Okay, that's all. Group number 2.
Yes, sure.
Okay, so is there production of heat in hydroelectric power plant? Sa process of producing electricity, is there production of heat involved for hydroelectric? Sige, let's start with heat input or heat resource. Naa ba for hydroelectric power plant? Yes or no? Group number 2. Na ba source of heat or heat input for hydroelectric power plants? Yes or no? Tubaga lang. Any representative? Group 2?
Yes, Chair.
Asa ato? For hydroelectric power plant. Nabay source of heat for hydroelectric power plants?
Solar, Chair.
Is it solar? Mhm. Ayo pila ang kuan, solar energy. Let's focus on the potential. Gravitational kato sa water, stored water in the dam. So is there heat input, heat resource for hydroelectric power plants?
No,
Sir,
Chair.
Okay. Yes, Judy.
answer.
Okay, for Sophia, there is no heat input, okay, or heat resource. That is correct. Wala may kuan to source of heat compared sa other power plants like geothermal. Asa sila gakuha heat for geothermal? 'Di ba? Earth's interior. For hydroelectric, wala siya heat source. Okay, next. Is there production of heat in hydroelectric power plant? Makaproduce ba og heat sa iyang along sa procedure or process? Is there production of heat? Group 2? Makaproduce bag heat sa hydroelectric power plants? Any idea? What about dato sa turbine? Rotation of turbines. Okay. So naay minimal production of heat sa pag-rotate sa turbines. Okay? Pero dili to siya magamit as electrical energy. Okay? So kibali waste lang to siya. Okay? Okay, energy transformation. Kindly summarize the energy transformation. Kagaling tong first for hydroelectric power plants.
Potential energy of elevated water.
Okay, then
Mechanical kinetic energy of rotating turbines.
okay,
Then
then
electrical energy from generators.
okay. So again, generators, these are devices that convert mechanical energy to electrical energy. So potential, mechanical, and then electrical. That is for hydroelectric power plants. Okay, what law is applied for hydroelectric power plants? Group 2. Only one lang for hydroelectric power plants. Mhm. Okay, first law. So what is the statement for first law of thermodynamics? Group 2. Wala gyud mo nag-on cam.
Energy cannot be created or destroyed. It can only be converted from one form to another.
Okay, correct. We cannot apply the second and third law kay wala may heat source. Okay. Sige. Any question for hydroelectric power plants before we will proceed to group 3? Wala na? Other groups? Any concern? Uy, tubag-tubag din. Okay. Sige, let's proceed to group number 3. Thank you so much for group number 2, hydroelectric power plant group. Okay, let's proceed now to group number 3. Fossil fuel. PowerPoint maker for group number 2. Kindly type the members be sa atong public chat. Members for group number 2. Okay, let's start na. Group 3.
Sure, wait lang.
Okay.
Electricity has been a vital part of our lives. It powers most of the things that make our day to day life, from our phones, laptops, to even our online classes. Without electricity, these things wouldn't be a reality today. But before electricity even reaches our homes, our gadgets and appliances, power and electricity must be processed in power plants. For today, we welcome you to our presentation.
Good afternoon, everyone. We will be talking about power plants that provide most of society's need for electricity. And for our presentation, we will be talking about fossil fuel power plants. But before we go on, we have to know what a fossil fuel power plant is. And for that, Nor, may you do the honors?
A fossil fuel power plant or power station is a thermal power station which burns fossil fuels such as coal or natural gas to produce electricity.
Now that can sound vague, but we'll explain more in depth about it later on. But before that, within a fossil fuel power plant are the fossil fuels that power the processes to produce electricity. What are fossil fuels, you may ask? Fossil fuels such as coal, crude oil, and natural gas are all considered fossil fuels because they were formed from the fossilized, buried remains of plants and animals that lived millions of years ago. Because of this, most fossil fuels have a high carbon content.
The first fossil fuel we'll talk about is crude oil. Crude oil or petroleum, which in Latin means rock oil, is a liquid fossil fuel made of mostly hydrocarbons. These oils can be found in underground reservoirs, in the cracks, crevices, and pores of sedimentary rock, or in the tar sands near the Earth's surface. These oils are accessed via drilling on land or sea or by strip mining in the case of tar sands, oil, and oil shale.
The second fossil fuel is coal. Coal is a solid yet carbon-heavy rock that comes in four main varieties, differentiated largely by the rock's carbon content: lignite, bituminous, and anthracite.
The third and last fossil fuel we'll talk about is natural gas. Natural gases, composed of mostly methane, natural gas is generally considered either conventional or unconventional, depending on where it's found underground. Conventional natural gas is located in porous and permeable rock beds or mixed into oil reservoirs and can be accessed by standard drilling.
With all the fossil fuels, a fossil fuel power station produces energy, which in the process also uses heat to power the process of energy transformation, as a fossil fuel power plant uses thermal power. In commercial power plants, the energy obtained from the combustion of fossil fuels is converted to electricity and also heat. When carbon and hydrogen in fossil fuels are burned, they, along with oxygen in the air, react to carbon dioxide and water. During this reaction, heat is released, which amplifies the reaction further. Mechanical energy or heat is converted to electrical energy in a turbine or generator to produce electricity.
Fossil fuel power plants also involve the transformation of energy. We burn or combust fossil fuels to generate electricity. The term for burning matter to generate electrical energy is thermal generation. Electricity isn't produced from combustion itself. The burning of coal or oil heats giant boilers filled with water. This transforms liquid water into steam. The steam creates a lot of pressure in the boiler. The pressure rotates a steam turbine. This drives a generator to produce electricity.
Energy gained from burning fossil fuels is converted to electricity and heat in commercial power plants. When fossil fuels are burned, carbon and hydrogen react with oxygen to carbon dioxide and water. During this reaction, heat is released, which further amplifies the reaction. Electricity is generated by the transforming of mechanical energy or heat to electrical energy in a turbine or generator.
The principles and laws of energy and thermodynamics are also applied in fuel power stations. And since fossil fuel power stations involve the transformation of potential chemical energy in the coal to the mechanical energy of the generators and turbines and to electrical energy, the first law of thermodynamics may be applied in these power plants. The first law of thermodynamics states that energy cannot be created or destroyed. It can only be converted from one form to another. The first law is used to categorize the performance of cyclic conversion system like fossil-fired steam power cycles or geothermal cycles.
Everything has their advantages and disadvantages, and the same can be said in fossil fuel power plants. The benefits of using fossil fuels is that it is an inexpensive method of generating and producing electricity. This is because taking coal, natural gas, and oil out of the ground is straightforward. Fossil fuels are easy to store and transport because of their high energy density.
Being easy to use and cheap makes fossil fuels seem like a good source of electricity. Yet, the cost to society of fossil fuels is much higher than their current price tag. Burning fossil fuels contributes to climate change. This is because it releases carbon dioxide and other greenhouse gases into the air. Electricity generation is one of the main sources of greenhouse gases. It accounts for about 25% of the global emissions. Burning coal for electricity releases large amounts of greenhouse gases.
Generating electricity with fossil fuels produces other pollutants as well. For example, burning coal and oil releases nitrogen oxides and sulfur dioxide gas. These pollutants can lead to acid rain, which harms soils, forests, lakes, and rivers. Burning fossil fuels, particularly coal, also releases particulate matter into the air. Particulate matter can lead to heart attacks, strokes, lung cancer, and other diseases.
Fossil fuel provides an expensive way to disperse electricity to many households, yet still, it provides many non-environmentally friendly risks that can affect nature in the long run. What may seem easy and cheap may not always be the best solution. Thank you for listening to our presentation and good afternoon.
Okay, thank you. Group number 3. So let's go back to the different types, the laws of thermodynamics. You mentioned only one, right? First law.
Yes,
Do you think second law, pwede sad? Second law of thermodynamics?
it's true.
Ano wala ninyo gi-appeal?
We only realized it after.
Sige, i-state na lang what is the second law of thermodynamics. Kaya pwede man siya sa fossil fuel.
That's true. The second law of thermodynamics states that the total entropy of an isolated system, or the thermal energy per unit temperature, that is unavailable for doing useful work can never decrease. And ma-apply siya sa fossil fuel power plants siya because it also has a heat source siya, na siya heat input siya from the burning of fossil fuels siya, and producing electricity siya.
Okay, so there's an increase in entropy for a fossil fuel. At the same time, heat will flow from hot to cold. Kay burning of fossil kay, of course, high temperature. And then, ma-distribute mo siya to the environment at lower temperature. So, you must include the second law of thermodynamics. Okay? So, kato lang ang kulang. First and second law dapat. It's okay. All right, thank you. Group number 3. Let's proceed to group number 4. Nuclear.
Good afternoon, everyone. This afternoon, we are tasked to report about the topic titled Nuclear Power Plants. When we speak of nuclear power plant, that is it is a thermal power plant in which a nuclear reactor generates large amounts of heat. This heat is used to generate steam, which drives a steam turbine connected to a generator that produces electricity. A typical nuclear power plant has an electric generating capacity of 1,000 megawatts electric. The heat source in the nuclear power plant is a nuclear reactor. As typical in all conventional thermal power stations, the heat is used to generate steam, which drives a steam turbine connected to a generator that produces electricity. The turbines are heat engines subject to the efficiency limitations imposed by the second law of thermodynamics. In modern nuclear power plants, the overall thermodynamic efficiency is about one-third or 33%. So 3,000 megawatt thermal of thermal power from the fission reaction is needed to generate 1,000 megawatt electric of electrical power. Nuclear power plants heat water to produce steam. The steam is used to spin large turbines that generate electricity. Nuclear power plants use heat produced during nuclear fission to heat water. But what happens during nuclear fission? In nuclear fission, atoms are split apart to form smaller atoms, releasing energy. Fission takes place inside the reactor of a nuclear power plant. At the center of the reactor is the core, which contains uranium fuel. Nuclear power plants are thermal plants. They use heat produced by nuclear fission to convert water into high-pressure steam. The steam drives a turbine generator to make electricity. Nuclear energy is created when uranium atoms are split in a process called fission. Fission releases a tremendous amount of energy in the form of heat. This heat creates steam that is used to turn a steam turbine. The turbine is connected to an electric generator, which generates electricity. Radioactive materials found at nuclear power plants include enriched uranium, low-level waste, and spent nuclear fuel. That is all. Thank you.
Okay, thank you. Group number 4, nuclear power plant. What is the energy transformation for nuclear power plant? Energy transformation. Samarina, I think you did not include it in your presentation. Group 4. Any representative to answer? Energy transformation.
Sure. Nuclear energy is converted into thermal energy is converted into mechanical, electric,
Mechanical to?
electric engine.
Okay. So how is heat produced for fossil fuel? I mean nuclear, sorry. How is heat produced for nuclear power plant? There are different thermal power plants. So isa ni si nuclear power plant. How is heat produced? or how is thermal energy produced in nuclear power plant? For fossil fuel, kay burning of katong different types of fossil fuel like coal, natural gas, so on and so forth. What about for nuclear power plant? Steam generated man gapon ni na power plant. The only difference is that ilahang heat source. Group 4, how heat is produced for nuclear power plant. It was mentioned sa reporter in her presentation. Okay, we have from Pauline, nuclear fission. Okay. What element is involved in nuclear fission? What element is involved for nuclear fission? Nuclear fission, the atoms will split. So, unsa na element ang present? Okay, very good. Uranium. Correct. Next question. Apa ba? Okay, what laws of thermodynamics can be applied? Sige, anyone? Group 4. What laws of thermodynamics? Okay, second law and napaisa.
First law, sir.
Okay, very good. First and second law. Okay. Thank you, group number 4. Let's proceed to group 1, last group, geothermal. Members of group 4, i-type lang in our GC. I mean, public chat. Okay, you may start na. Jade is not around. Marinel. So, kinsa man ang replacement? Hello? Group 1.
Not sure.
Okay, sige.
Good afternoon, classmates. Good afternoon, Chair Maita. We are Group 1 and we will be presenting about geothermal power plants. Geothermal power plants are used in order to generate electricity by the use of geothermal energy. They essentially work the same as a coal or nuclear power plant. The main difference being the heat source. There are three main types of geothermal power plants: dry steam plants, flash cycle steam plants, and binary cycle plants.
Janessa, are you talking? We can't hear you. So, kinsa nagstorya? Ay, wala pa? Group 1?
What is geothermal energy? Geothermal energy is the thermal energy within the Earth's interior. Because heat is constantly produced inside the Earth, geothermal energy is a renewable energy source. The first law of thermodynamics is the application of the conservation of energy principle to heat and thermodynamic processes.
What is heat? Heat is a form of energy created from the movement of atoms and molecules, which are the smallest particles that make up all matter. The temperature of an object tells us how fast its atoms or molecules are moving. How is heat produced? Heat is produced by mechanical and electrical machines as well as when one thing rubs against the other. The production of electricity from a geothermal source is about producing work from heat. Electricity production from heat will never be successful unless appropriate respect is paid to the second law of thermodynamics. Energy is utilized in two forms, as heat and as work. The second law of thermodynamics states that the total entropy of an isolated system can never decrease.
Sir, I'm done, sir.
Okay, done?
Wala pa, sir.
Ay,
The steam turbine generator, condenser, cooling tower, gas removal system, and hydrogen sulfide abatement system are the main components of a geothermal power plant at the geysers. Thermal energy in the form of pressurized steam flows from wells to the power plant via pipelines. Next, please. Hot water is pumped from deep underground through a well under high pressure. When the water reaches the surface, the pressure is dropped, which causes the water to turn into steam. The steam then spins a turbine, which is connected to a generator that produces electricity. Next. That is all. Thank you.
okay, group 1. Let's start with what is geothermal energy again? Geothermal energy. Who would like to
Sure.
answer?
Geothermal energy can be harnessed by drilling wells into the productive zones, and geothermal is a type of renewable energy taken from the Earth's core. It comes from heat generated during the original formation of the planet and the radioactive decay of materials. This thermal energy is stored in rocks and fluids in the center of the Earth.
Okay. How is heat produced or geothermal? What is your source of heat here for this power plant? Source of heat? Group 1. So
Ano,
this
Chair?
can okay.
Heat within the Earth, Chair.
Okay, within the Earth's interior, or that is also known as geothermal energy. So what is the energy transformation for geothermal power plant? Summary lang. Energy transformation.
Geothermal power plants convert heat energy to electricity.
Thermal energy, then 'di ba ang gamit ana is steam man? So from thermal to mag-rotate man din ng turbine using the steam.
Thermal to mechanical, Chair.
Okay, thermal to mechanical, and then what's the last energy transformation?
Electric.
Okay, electrical. So what device is used to convert mechanical to electrical?
Turbine.
To electrical. Mechanical to electrical.
And generator, Chair.
Okay, generator. Correct. So what is your working fluid or substance here for geothermal power plants? Working fluid or substance? Same sa fossil fuel and even sa nuclear power plants.
Steam.
Okay, very good. The steam. Okay, question for group number 1. Other groups, any concern or clarification? Okay, if none, thank you so much, group 1. A round of applause, everyone. Group 1, 2, 3, and 4. So all of you will have 10 points for the presentation. So next, let's proceed to our next activity, worksheet. Kindly proceed to Silid and download the Word file. You only have 5 minutes left, so that will serve as your assignment. Deadline for the worksheet activity will be on Friday, 11:59 p.m. You have 2 problems there. Kindly download. Answer in GRESA format. This is individual ha, di na siya by pair. For our problem solving worksheet. Nakita na? LT. Kada sa galing tadi mag-meet? 9C. Third session, next meeting. Mag-meet man ta tomorrow, no? I know. I did. Yes, mag-meet data. 9C datong dili. 9H, tomorrow mag-meet man ta. So that will be our third session. So LP number 1. So please do study chapter 18, work and heat, test types, identification, multiple choice, matching type, problem solving, and then constructed response. Please study the energy transformation ha in all types of power plants. Magawas na siya sa LT. Question? By the way, na-publish na worksheet number 1, ay number 2. Nakita ra? Ay, okay. Thank you, Sophia. Answer in GRESA format. Masasa na ninyo if you have clarification, especially for number 1 problem. For number 1, you need to solve first for work done using the equation. Anang clue na akong gihatag. Solve for work. And then your unit of heat there must be in joules. Kaya ang specific heat kay in joules man. Sige, basa sa ang problems. Number 1 and number 2. If you have clarifications, you may ask na. Okay na? 9H. Kahilom bas payag. Namalong nog kamo. Okay, wala na. Sige, let's have our closing prayer. Prayer leader. Prayer leader.